Our topic for today is serverless edge orchestration. It's a concept of how we think to marry between serverless and edge, and how orchestration should look like if we are to deploy a real edge solutions and real edge use cases. My name is Rozin. I'm coming from AT&T Israel. AT&T Israel has a huge department of people that works on cutting edge technologies of network communication. AT&T is heavily committed to the open source community, and we are contributing to ONAP, to Akraino, to other open source consortium like ONAP, and really AT&T is in the past few years is really committed on how to open the network fully within SDN and virtualization concepts. And this is what I'm going to show you is yet another concept of how we think about edge and how we think about serverless. So if we are to talk about 5G, and I think some of you already heard that AT&T is really going to deploy 5G in the upcoming month. And 5G, I think one of the key enablers of 5G is really edge computing. Edge computing is a key factor, key enabler for 5G. And if we are to bring use cases like virtual reality, augmented reality, connected car, IoT, industrial IoT, those kinds of advanced use cases, we cannot do it without 5G. We cannot do it without the bandwidth. We cannot do it without the low latency delay. And mainly, we cannot do it without edge computing. The thing with edge computing is that edge is like everywhere. It has a lot of points in the network that we can use as part of our edge architecture. It's not like the data center. It's not even the CO, the central offices that we have hundreds or thousands, depends on the country. We have more. We have thousands and more than that. So we have a decentralized architecture. It's not like I have few data centers that I need to manage. I really need to manage a lot of endpoints. So there are key benefits of decentralized architecture, but also a lot of drawbacks, a lot of challenges that we need to overcome. We know that edge computing will give us the ability to mitigate a lot of latency issues, and with that bring cutting edge low latency use cases, again, like VR, AR, and others. And it's essential for IoT. Without that, we cannot bring the workload closer to the customers, closest to the users, and really deploy IoT solutions. So edge is a key enabler for 5G. This is the promise, but it comes with a lot of challenges that we need to overcome if we are really to deploy edge solutions. One of them is really, we said, it's a decentralized architecture, thousands of locations. How are we going to manage so many locations? How we're going to orchestrate to so many locations? How we are going to do the monitoring of it? This is a real challenge. We know that the edge itself is going to be deployed in many different locations that has different kind of footprint, different kind of spaces and sizes, and we need to bring our workload to a variety of places that looks differently. Those of you are familiar with UCPE kind of a base. When I'm virtualizing my customer premise, this is one use case this is maybe one platform to to call edge and deploy workloads. We know about the Mac that comes with 5G, that comes with a mobility kind of use cases. So we have different kind of infrastructure that we need to work with. Limited in cooling and power, limited in compute resources, but not only limited in the amount of compute, also with the reliability of the computes themselves. If we are to deploy things that has, problems with cooling, problems with power, different kind of places, the compute resources sometimes won't be as reliable as I have in the data center, which is fully managed. Doesn't matter if it's public or private, right? So the compute resources, not only that they are limited, they are not even reliable enough. Still, if we talk about few use cases before, we have a significant workload that we want to put on the edge platform and a large variety of them. Obviously, VR, AR has a lot of traffic, and not all of traffic passing through this because it's video. CDN again. IoT, less traffic, but more bursty in its nature because of the events. So we have a significant workloads, and they are significantly different from one another. And we would like to have a platform which is open enough to run third-party software on it. Okay, and when we say third-party software, is like, bringing your use cases, bringing your workloads, let's innovate on it. We need this kind of an ecosystem when we talk about edge. So what we feel is that orchestration, and with that, service assurance, monitoring, and other aspects are significantly different between a data center and an edge cloud. So some of the things we already talked about, the location of the application at the cloud, pretty much location agnostic. At the edge, the location of where I'm going to place my workload is very significant. For example, if I would like to deploy CDN kind of application closer to my users, and my users has, maybe I can predict some of their behaviors when they are using, videos over the top, right? But I would like to put my CDN application closer to the users themselves, okay? Because I don't want the traffic, the video traffic, which is enormous, to traverse along my pipes in the network. So the location is significant. If I'm driving my car, and my car now is a connected car and has a lot of events, then I would like to capture those events very close to the car and not, take all of the events to the central cloud, and with that add more and more delay to what I can do with those events. So the location in the edge is not agnostic. It's important to do the orchestration, which has a location-based kind of nature. The mobility of the workload is also important, because in the central cloud, you really don't care. You put your workload in the central cloud, and it's there for months or years. You don't really care about moving it from one location to the other. While at the edge, the nature of some of the use cases is the need to take the workload and move it from one edge to the other in order to continue keeping the proximity to the nodes, to the users, always in a very small kind of a proximity. So mobility is also very important, and how orchestration would look like when I need to be location aware and I need to mobilize the workload automatically. The dynamicity also is important, and it comes with mobility naturally. In the central cloud, the static workflow, the workflow are static most of the time. When you're deploying there, it's there. While, at the edge, there is also not only the location and the proximity, but also the time. In some times of the day, I would like this workload to be active on some location, and sometimes I don't. I can predict some of the behavior, and some of the use cases are harder to predict. So I would like to turn up and turn down workflows from the edge in automatically kind of a fashion. This is the dynamicity of the workloads. In terms of architecture, if I'm basing my orchestration, my workloads on a public cloud, hybrid cloud, I'm getting some kind of a PaaS. I'm a platform as a service. I don't care about the infrastructure. And mostly in the central cloud, the infrastructure is pretty much the same. Doesn't really matter if it's OpenStack, doesn't matter if it's Azure. It's pretty much the same. But if we are talking about edge, some of the infrastructure is completely different. I will have there a PNF, a physical devices. I would have their UCPEs, which are partially virtualized. I will have MEC. I will have a variety of infrastructure, and I need to create from those different infrastructure the same kind of a platform. The same kind of platform of which I can do later on orchestration, monitor, and configuration, and so on. So the edge brings heterogenic nature of the infrastructure itself. In terms of latency, of course, the edge is closer, the latency can be mitigated. I can bring sub 5 milliseconds, sub 20 milliseconds, depends on the infrastructure and depends on the use cases, which in central cloud, for some of the use case, I cannot. And the availability of the resources, as we mentioned, in the cloud, I have the resources are always available, the computes are there. If I have redundancy capabilities or not, resources are always there. At the edge sometimes, and most of the time, I will get to the max capacity of the resources. I won't have all the resources that I need. And what will happen then with orchestration? In terms of monitoring, again, so if I would like to do real-time kind of activities, if I would like to respond to events that happens very quickly, like in AR, VR, in some of the use cases of IoT, like connected car, I need to do the collection of those events very, very close. So I need to do the collection or deploy the ability to collect those events at the edge platform and not at the central cloud. So this is another key factor of how we are trying to bring a zero-touch kind of capabilities to the edge cloud, of which in the central cloud, I do it completely different. In terms of the architecture, edge is going to be made from different vendor, different infrastructure, as we mentioned, and we need to bring some kind of standardization to the way we are going to collect this information. We need to have the same kind of metric, the same kind of API. This is a real challenge, while in the central cloud, depends on what you are using, it's pretty much homogeneous. In terms of distributed root cause analysis, if you want to identify root cause analysis at the edge, it's much more challenging because of the variety and the amount of nodes, amount of location, while at the central cloud, again, it's very difficult, as you've heard in many lectures today, but it's still a simpler problem that we have at the edge. And with that, I'm resonating with Rona lecture about microservices. Microservices, you can take the same analogy to the edge here. Distributed closed loop, location. By the way, closed loop, for those who are less familiar with the term, is the ability to respond to an event automatically with an action. I can, for example, understand that I have 80% of CPU utilization and decide on a policy that would say, for example, spin up another VNF, have more VM or more compute capabilities, and everything is being done automatically. I can respond to event automatically. So location latency takes a major role in recovery and mitigation plan. Recovery is much more simpler if we are talking about a public cloud or central cloud. Again, it's simpler, it's still difficult, but it's simpler. And when we talk about central cloud. Again, when we talk about edge, data management is also very important, because if I don't know exactly what is going to be the location of the application, or I have the mobility of workloads along the way between edges, I need to bring the data for the workloads themselves in every location. So I need to have like some kind of a grid and data pipes capabilities that can bring and bridge a lot of data to many different locations. So data management at the edge is, again, much more problematic. At the central cloud, everything is placed or stored in some kind of a database mechanisms, with redundancy, without, with high availability, without. At the edge, we need to distribute, we need to have partitioning in order to do this, and it's much more difficult to make everything, intact, synchronized, and the data available to all of the nodes. In terms of high availability, no problem to have high availability solution on the central cloud. We have this today. We are doing it for quite some time. At the edge, sometimes, maybe I don't need to have this kind of capability. Or maybe for some of the use cases, I don't care. Maybe for some of the use cases, what was lost. I don't need to have this kind of capabilities. So it's different in that way as well. Latency requirements prevent using a database for the central cloud. If I need to mitigate latency, maybe I don't need to store some of the things. At the central cloud, it's completely different. And the mobility and availability of data on the edge node, and again, the environment is dynamic. The data needs to be available for all of the nodes throughout distribution. This is like the grid kind of capabilities that we are talking about. So if we are, and we can continue on with security and other aspects of the cloud, we definitely need to start defining ourselves what would be an edge operating system, how edge operating system orchestration, monitoring, configuration would look like, and what is the edge operation system manifesto. So with that, we need to treat the edge as like a big distributed compute, where I need to place my workload, my resources, whenever I can, wherever I can. It's like, you can imagine like an abstraction layer of compute above all of my edge cloud infrastructure. We need to harness the architecture. We have now a architecture that is very, very distributed. It has within it, because this architecture is distributed architecture, we have in it I would say, built-in security in it. One site is down, doesn't matter that the other site is down, right? One site is being attacked, another one is available. So I have, once I have a distributed architecture, I have a built-in security capabilities that I can use. How I can use this infrastructure for reliability and availability. We need to harness this kind of an architecture. Data is available everywhere on the edge in order to mobilize workloads. Execute workloads anywhere on the edge network. Intelligent resource management, this is key. This is key. Again, the dynamicity. Some of the time I need a workload, some of the time I don't need a workload. The location itself, the mobility of it. This is intelligent resource management with location-sensitive workloads. Expect application beyond edge boundaries. It means that some of the use cases would need an edge presence of the software, and some of them will need also a cloud-centric, and how one may have this kind of a hybrid cloud capability where edge is built into this kind of infrastructure. And of course, no single point of failure from the architecture itself. So, as I mentioned, AT&T is investing a lot of time and a lot of money in building open source communities around the operating system of AT&T network. This is ONAP. ONAP is an open source, very big open source part of the Linux Foundation. And another one, like a broader kind of open source, is Akraino, Edge Stack, AT&T, and other companies like China Mobile, China Telecom, and other started to build up what Edge would look like, what is going to be the stack that we are going to use in order to perform Edge in many different kind of portfolios, the infrastructure and the platform itself. We are completely adopting cloud native paradigm for deploying the Edge. We are using containers, which has a smaller footprint than VMs. If we talked about the fact that Edge has limited resources, then containers give us the ability to start and mitigate the problem where we have an infrastructure that has less compute power, and compute has a smaller footprint than VMs. With that, it's improved resource utilization to some degree, and we are using microservice architecture, which you've heard that we are yet able to control its behaviors, its nature, its complexity. And with that, we know that integration of new microservices is very complex. It's still a complicated problem. Still, permanent allocation is something that we don't want to allow at the edge, at least for some degree, because if my resources are scarce, if my resources are limited and not very reliable, I would like to have a nature where I don't have a permanent allocation of resources. If I have application that doesn't use its resources, I would like to do sharing of those resources with other application, right? So we need to mitigate that. Container is still a large execution unit. So how can we try to answer those kinds of challenges? And with that, we think that serverless has a key factor in it, function as a service. If we are breaking our software from the monolith to microservices, why not to break some of the microservices based on the use cases to functions? So I believe this community knows about serverless quite a lot, about function as a service. I'm sure you know and uses some of the services that are out there in the industry for the public cloud, like coming from AWS, from Google Cloud, from Azure. We know that functions are a unit of deployment and scale. This is what we are looking for. It's like microservice in that manner. It's no machines, no VMs. And with that, we have a level of abstraction of, if I'm writing a function, I have the level of abstraction of not need to, to take care of how my code is going to interact with servers, right? It's a unit of scale. I can scale function, which is great. This is what we wanted. We are never paying for idle. If I have a function and the function is not getting inputs from any event or doesn't do any processing, I'm not paying for idle. And this is, who is the third party that writes the function. But on the other end, if I'm giving this kind of a platform, it's also interesting because I can use the resources that I gave to this function to other functions as well, right? I can take the resources, the compute resources that the function needs, and when it doesn't operate, I can take the same compute resources and give it to different function, and this is give me the ability to move away from permanent allocation of resources. It's really bring your own code, and very promising. So those of you who less familiar with that, a function gets an input. It could get an input from a variety of triggers, and it operates some kind of a business logic that does some kind of a calculation. It could be whatever. I can chain functions. Function can call another function, in order to get the output that I need. And with that, once the function is completed its cycle, it's in idle phase, I can take the resources and use them elsewhere. So what serverless is good for? It's good for data collection and enrichment, mobile backhauling, file processing, web backend, IoT backend. If we are talking about edge, this is really it. And streaming processes, it's not good for long processes, persistent processes, databases. If you have use cases like that, probably need or hybrid solution or not use serverless at all. So we built something and we showcased it in the Open Network Summit in Amsterdam 2 months ago, and in the SDN NFV World Congress in The Hague a month ago. And also it's published, it's called Edgility, and it's really marrying serverless with the edge. We took Akraino, we took the edge stack out there in the community, and we added a serverless layer above it. You can call it a data pipe kind of a service, intelligent data pipe kind of a service that can take few events, right? Process and call functions and activate functions that does some kind of a business logic, whatever you'll decide. And we gave some monitoring capabilities around it and really orchestrate the entire thing. We orchestrated the edge stack itself, the Akraino itself, we orchestrate the functions, and we showed one use case that demonstrate that this is possible and this is available. And on top of everything, we took all the things that we did and we open source it. So it's open source now in the community, in the Akraino community. It can be deployed by any one of you. So what we build is like this. The lower level, the one at the gray, comes from what Akraino edge stack brings. It brings much more than that. You will see later in another slide. But we used this kind of a deployment, and we've integrated VernaMQ, a Kafka, and a Kubeless. Kubeless, it's a function as a service, a platform that is from the house of Kubernetes, has a lot of benefits of integrated to Kubernetes itself. And we wrote few functions that demonstrate and IoT use cases. So on the left-hand side, we are capturing events. We are processing those events. We are managing functions, call functions. Each function does its business logic. And after that, we can use this business logic to showcase a use case. We use ONAP as the operating system of AT&T's network and the open source community to design and to deploy the Akraino edge stack, the edge cloud pops themselves that has Kubeless, the Kubernetes cluster, and the edge platform. So we use ONAP to orchestrate the edge, and then at the edge we orchestrate all the functions. In ONAP, inside the service orchestration layer, there is Cloudify orchestration, and we use Cloudify orchestration to showcase this. And we showed one use case, very thin use case of intelligent transport system, the ITS. Those of you who are less familiar with ITS, a big notion of how cities would look like, how transportation would look like when we will have a much more, I would say, intelligent car, a connected car. And we showcased a problem in the road. This is the Boston area, Boston downtown area. A problem in the road, some of the roads are blocked, partially blocked. We are recognizing each car is represented by a function instance, and we getting all the location information of each one of them, and we are routing each one of the cars to a different kind of a route in order to, we are capturing the event, capturing all the information, calculating, and give each car a different kind of a route just to showcase that this data pipe is working. And with that, by the way, we did the deployment of the function mobility, and the manual scale out when we need. When we have a lot of cars in one location, we can scale and have more resources at the edge. In terms of our demo architecture, the demo architecture, you can see that we have an event generator. The event generator generates each one of the cars. Each one of the cars has a location. The location is changed all the time, and we are capturing all the location information. We have the IoT gateway to get all the events coming from the car. This is the lower layer. We have the Faas platform, which is, again, kubeless. And we have three functions. One represents Mazda, another one Toyota, another one Ford. And we have a monitoring capabilities for all of the functions. We are using Prometheus and Grafana to monitoring the raise of the function when they are being called. So we've heard, right, that monitoring is a big problem for operations from other lectures. And we know that we have the tools to start visualizing these kinds of stuff for operations to manage the cloud itself. In much more details, this is, by the way, is the service design and creation part of ONAP. We also developed this, one of the biggest community in ONAP. And you can see here that we have a representation of how to create in a self kind of a fashion a blueprint of the entire deployment. You can see that we have three functions below. We have the kubeless, we have the IoT gateway. Each one of them is represented with a blueprint that I can later on deploy with the Tosca template. I'm connecting everything. It goes to orchestration, and the orchestration is orchestrating the entire thing. And this is how our code contribution to Akraino. This is the Akraino stack. This is how it looks like today in the Akraino community. And we open sourced the entire thing. In terms of our next step, so if we are returning to the Edge Manifesto, if we are returning to the problem that I just mentioned, if we solve all the problem, of course not. We think that serverless gives us the capability to showcase and solve the problems of permanent allocation of resources. Serverless gives me the ability to not provide a permanent allocation of resources. But we didn't solve the entire orchestration problem. We didn't solve the entire monitoring problem, right? But this is what we are going to do at the next level of agility. We're about to start the deployment, the development of the second phase. The second phase is really going to tackle the ability of providing dynamicy of the function, and we are going to do it with machine learning. It means that we would like to predict behaviors for specific use cases. It could be, for example, we know that people are watching television usually at the evening time, and if I have a location-based kind of orchestration, I can orchestrate vCDN application. I can do a prediction with machine learning of how traffic of cars is look like, and with that, scale out more resources for the edge in order to accommodate with more traffic. And we are welcome everyone to join us to this journey and to work with us under the Akraino community, developing this very challenging concept. Questions?
Just wondering from the business point of view, you demonstrated a case about IoT of the Boston case, but why should be driven by the edge? You can solve this currently by data center.
Yeah, that's correct. The use case that we showed is really simple. right? It's really simple. It's writing few functions. I don't need to, by the way, for the use cases that we show, I don't need to deploy it at the edge, of course. I can do it in central cloud. The use case that we showed is just to demonstrate the ability of this software, which is an open source software, to answer this kind of problem. And the functions themselves could be a VCDN function, AR, VR function that will, you know, I would think it will resonate more with your opinions around the edge. But this is just showcase the capabilities. Yeah.
I believe I remember from earlier slides you mentioning making data available to all applications across the edge. I'm not sure how that is realized in the architecture you're showing us.
So I'm not sure it's there, but we have also databases to persist some of the information at the central cloud, and this information is being exactly. As we mentioned, most of the interesting use cases will need some kind of a hybrid solution where you are deploying some of the workflows at the workload at the edge, and you're giving the real-time kind of use cases there, while some of the information is going to be managed by the central cloud, and you need to access it for a non-real-time kind of flows. If you have a data that you need to react on it very quickly, very fast, you want to have it at the edge, and there is the question if you need a database or not. And if you have a non-real-time analytics, machine learning and other kind of stuff that you need to do, you're probably going to deploy it. Thank you very much, guys.
Thanks.